Bismillahirrahmanirrahim. This problem is related to complex analysis from chapter analytical function, Cauchy-Riemann equation, and harmonic function and orthogonal system, etc. So this problem is find the analytic function of which the real part is e to the power minus x square minus y square multiplied by cos y plus 2x by sin y. This is real value. We write real value with u. Let u is equal to this real value of analytic function. We write it as u. We know that function analytic function fz is equal to u plus iv. We have only given the real value u, which is equal to e to the power minus x square minus y square cos y plus 2xy sin y. Now we apply Millen-Thomson method to find the analytic function fz. So we have to find partial differentiation of u with respect to x and y. So we first find partial differentiation of u with respect to x. Here we see that e to the power x and this are two functions. We can consider e to the power x first function and this as a second function. So we differentiate multiplication of two function as first function as it, write as it, differentiation of second. Because we differentiate with respect to x partially, so for x y is constant. When we differentiate this function, we differentiate with respect to x, we get 2x because y is constant for x, therefore its differentiation is 0, but this multiplied by cos y. Next term plus like this 2y sin y is multiplied by x, so we take 2y sin y as cos y. Here constant which is multiplied to x, so differentiation of x with respect to x equal to 1. First function as 8, differentiation of second plus second function as 8 x square minus y square cos y plus 2xy sin y, differentiation of first which is equal to e to the power minus x, but it is not x, so differentiation of minus x with respect to x we get minus 1. Here we apply differentiation of two function first and second. We apply here first function as a differentiation of second function plus second function as a differentiation of first. We have applied this formula here. Now I write it's again as e to the power minus x is common, and both term, there are two terms, this term and this term, and this minus 1 make this plus sign into negative sign. So value of del u over del x equal to e to the power minus 1, which I take from common from bracket, so we get now 2x cos y and this term plus 2y sin y. Now we write minus 1 here, minus curly bracket I apply for this bracket, curly bracket here, and write these terms x square minus y square cos y plus 2xy sin y bracket close and square bracket also close. Now we should must find the value of del u over del y. For applying Millen-Thomson method, we have to find del u over del x, also del u over del y. Before finding the del u over del x, we say del u over del x equal to function phi 1 xy as application of Millen-Thomson method. Now we find this value, it means del u over del y. Because this is partial differentiation of u with respect to y, so here u e to the power x constant, which is multiplied factor, so we take e to the power minus x from del over del y, but we have to differentiation these values, which is a bracket sorry for interruption of power supply. We differentiation of this bracket with respect to y. X square minus y square cos y plus 2xy sin y is equal to e to the power minus x. Now we differentiate this value because x is constant for y, so differentiation of x square is equal to 0 and y square is equal to 2y. First function as 8 first function as 8, differentiation of second plus second function as 8 x square minus y square, differentiation of first function minus sin y. We apply this formula here first and second function. I consider cos by first function and this value second function. There is no necessary you consider cos by as first function. You can consider second and first. Now we go to this value, and also here 2x is a constant for y, so we take it from outside bracket, curly bracket, and apply first and second function, differentiation of two function, first and second. So differentiate first function as 8, differentiation of second plus second function as 8, differentiation of first, which is equal to 1, close bracket, and also this square bracket, close square bracket. So we get del u over del y is equal to e to the power minus x minus 2y cos y, and also this sign convert to minus because of this minus sign multiplication, so we get minus x square minus y square sin y plus 2x, we open this bracket, curly bracket, so we get 2xy cos y and also 2x multiplied to this value, so we get 2x sin y. We say this function phi 2 xy. Now we apply Millen-Thomson method to find analytic function y, the real part of the analytic function, which is we denote by u. We know that Millen-Thomson's method f dash z is equal to phi 1 z comma 0 minus I phi 2 z comma 0. So we are able to find f dash z, and after it we can get fz by integrating it with respect to z. First we write the value of phi 1 z comma 0. Here we have phi 1 xy, which is equal to this value. Here we put the value of z phi 1 z comma 0. So we put z in place of x and 0 in place of y. So we write all values of this function phi 1 by replacing x y z and y y 0. We write here this value, so we get e to the power minus z, curly bracket, I apply curly bracket, 2z in place of x, cos put the value of y equal to 0, plus 2 into 0, we put 0 in place of y into sin y. You can put direct value it as a 0, but I write whole values. After it I have to because there is no need of this bracket, square bracket, so I convert this bracket by square bracket, because there is lack of brackets after it. Minus, we apply this bracket and put z in front in place of x and 0 in place of y. Cos 0 plus 2z into 0, I put 0 in place of y and z in place of x according to phi z comma 0. Sin into sin 0, we close the bracket, square bracket, also this bracket. After this after putting this value minus, put the sign of minus I, and we have to put this value phi 2 z comma 0. We have here phi 2 xy equal to this value, so we put the value of z, put the z in place of x and 0 in place of y in this value, which is equal to phi 2 x comma y. So we write in this value in here, e to the power minus z bracket minus 2 into 0 into cos 0 minus, you can see this value, and phi 2 xy, I put z in place of x and 0 in place of y. Here I have write this value, and now I want to write this value, so put z in place of x and 0 in place of y. Sine 0 plus you can write these values directly. I write it with detail because of I consider your problem. I write now this value 2z into sine y means 0, sine 0. Close bracket and solve this value. After solving this, we can find the value of fz. So we write e to the power minus z, bracket here, cos 0. We know that value of cos 0 is equal to 1, and 0 multiplied to this value equal to 0 minus curly bracket z square minus 0 is equal to z square, cos 0 is equal to 1, and 0 into this value equal to 0, so we can write this value 0, whole value 0, and close this bracket. After it we write minus I e to the power minus z, and this 0 multiplied by this value equal to 0, and also we know that sine 0 equal to 0, so 0 multiplied to this value also equal to 0, and also this 0 is present here in this factor, so all this value 0. Also last term is 0 because sine 0 equal to 0, 0 into 2z equal to 0, therefore this portion is completely 0. So we get f dash z is equal to e to the power minus z into 2z minus z square only, because 0 multiplied by I e to the power iz equal to 0. So we not write here because it is useless. What we have to find fz. So we have to integrate it. So I write integrating it with respect to z, we get left hand side equal to fz, because this is derivative of fz with respect to z. So different integration of f dash z equal to fz, and integrate this function e to the power minus z, 2z minus z square. There are many methods to solve this problem. We know that when we integrate, we have to add a constant. We write c here, constant of integration here. You can apply many methods to solve this. I consider here 2z is differentiation of z square. So you can also apply the special formula e to the power minus z multiplied by this value and derivative of this. So you can apply formula, but I not apply that formula, but I multiply e to the power minus z into function, and same procedure, and apply same procedure as that formula generate. So I not use that formula, but use method of formula generation. So I leave it without any calculation here, and since differentiation of z square equal to this, and this equal e to the power z equal to this, so we apply only here integration y parts. So we consider z square is first function and e to the power minus z second function and apply this formula. Integration of first and second, multiplication of first and second equal to first function as it, integration of second minus differentiation of first and integration of second, and after multiplying these values integrate with integrate whole this value. So we apply this formula here after considering z square as first function and e to the power minus z second function. So first function as it, integration of second e to the power minus z dz minus differentiation of first means z differentiation z square and integration of second e to the power minus z and multiplication of these value integrated with respect to z. Plus c, write plus c here without any change, only apply integration by part here, because we know that this value will cancel out from here by this value. Z square, I write z square, integration of e to the power minus z equal to e to the power minus z, what we consider, but with we divide the coefficient of z which is equal to minus 1. So we divide minus 1, this is integration of e to the power minus z minus differentiate z square with respect to this, so we write 2z here and integrate integration of e to the power minus z same value, so we write it's e to the power minus z upon minus 1 and write dz after multiplication we integrate with respect to z, close bracket plus c. We can now open this bracket, so we get e to the power minus z 2z dz which is equal to fz all value which is the right hand side, and I open this bracket, so this sign change to plus with this sign, so we write plus here and z square into e to the power minus z. This sign change by minus 1 because minus 1 is a constant, so we take it to sign of integration and change this sign. What this open this bracket, we again change this sign which is equal to minus and write this as write e to the power minus z first and 2z second, because I want to match this value which can easily notice, and we can cut cancel out it because sign of these value are different but numerical value is equal. Plus right plus c, left hand side equal to fz. We have to find value of analytic function fz which is equal to with z square to power z plus c only. This is our solution to this problem. It is z square to power minus z plus c. Thank you very much indeed for listening me. Wa akhiru dawana alhamdulillahi rabbil alamin.